Class 1 Group D motors are designed for environments where flammable vapors or gases are present in sufficient quantities to create explosive or ignitable mixtures. When using these motors in ventilation systems to remove flammable vapors, strict adherence to the National Electrical Code, or NEC, is essential. Several key requirements must be followed to ensure safe operation. Firstly, the motor's location is critical. The NEC mandates that the motor be positioned at least 10 feet away from any potential ignition sources. These sources include open flames, sparks, and hot surfaces. This spatial separation minimizes the risk of vapors igniting due to the motor's operation. Secondly, the motor must be housed within an explosion-proof enclosure. This enclosure is specifically designed to contain any internal explosions that might occur due to the presence of flammable vapors. The enclosure prevents the explosion from propagating to the surrounding environment and igniting external vapors. These enclosures are typically constructed from robust materials like cast iron or aluminum to withstand the pressures generated during an internal explosion. Thirdly, proper sealing of the enclosure is vital. The enclosure must be tightly sealed to prevent flammable vapors or gases from entering. This ensures that the atmosphere inside the enclosure remains non-explosive. Gaskets and other sealing mechanisms are used to create an airtight barrier. Fourthly, grounding is a critical safety measure. The motor must be properly grounded to prevent the buildup of static electricity. Static electricity can discharge as a spark, potentially igniting flammable vapors. Grounding provides a path for static charges to dissipate safely to the earth. When installing a Class 1 Group D motor for ventilation, placing the motor outside the roll-out room may be necessary to maintain the 10-foot separation from ignition sources. The explosion-proof enclosure must be correctly selected and installed to meet the specific requirements of the environment. Consultation with a qualified electrician is highly recommended if you are unsure about any aspect of the installation process. Their expertise ensures compliance with the NEC and safe operation of the motor. The NEC provides detailed guidelines for the selection, installation, and maintenance of electrical equipment in hazardous locations. Understanding these guidelines is crucial for ensuring the safety of personnel and property. Regular inspections and maintenance of the motor and its enclosure are also necessary to maintain their integrity and functionality. These inspections should include checking for any signs of damage, corrosion, or wear. Additionally, ensure that all seals and gaskets are in good condition and properly installed. Verify that the grounding system is intact and functioning correctly. If any issues are identified, they should be addressed promptly to prevent potential hazards. Explosion-proof enclosures are designed to withstand the force of an internal explosion without rupturing or allowing flames or hot gases to escape. This is achieved through robust construction, precise machining, and the use of flame paths. Flame paths are narrow gaps or channels within the enclosure that allow hot gases to escape while cooling them to a temperature below the ignition point of the surrounding flammable vapors. The width and length of these flame paths are carefully controlled to ensure their effectiveness. Different types of flammable vapors and gases have different ignition temperatures and explosion characteristics. Therefore, it is essential to select an explosion-proof enclosure that is specifically rated for the type of flammable substance present in the environment. The enclosure's rating will indicate the specific groups of flammable substances for which it is approved. The NEC classifies hazardous locations based on the type and likelihood of flammable substances being present. Class 1 locations are those where flammable gases or vapors are or may be present in the air in quantities sufficient to produce explosive or ignitable mixtures. Class 1 locations are further divided into divisions based on the probability of the flammable substance being present under normal or abnormal operating conditions. Group D refers to specific flammable gases and vapors, including acetone, ammonia, benzene, butane, ethanol, gasoline, hexane, methane, naphtha, natural gas, propane, and toluene. When selecting a Class 1 Group D motor, it is important to consider the operating temperature of the motor. The motor's surface temperature must remain below the ignition temperature of the flammable vapors in the environment. The motor's nameplate will indicate its maximum operating temperature. Temperature codes are used to classify electrical equipment based on their maximum surface temperature. These codes are typically expressed as a T followed by a number, such as T3 or T4. Each temperature code corresponds to a specific maximum surface temperature. For example, a T3 temperature code indicates a maximum surface temperature of 200 degrees Celsius or 392 degrees Fahrenheit, while a T4 temperature code indicates a maximum surface temperature of 135 degrees Celsius or 275 degrees Fahrenheit. The selective motor's temperature code must be appropriate for the flammable vapors present in the environment. In addition to the NEC requirements, other applicable codes and standards may also need to be considered. These may include local building codes, fire codes, and insurance requirements. It is important to consult with the relevant authorities to ensure compliance with all applicable regulations. The selection and installation of a Class 1 Group D motor should be treated with the utmost care and attention to detail. The safety of personnel and property depends on it. Proper planning, careful execution, and adherence to all applicable codes and standards are essential for preventing explosions and ensuring a safe working environment. Remember that electrical work in hazardous locations should only be performed by qualified and experienced electricians who are familiar with the specific requirements of these environments. They have the knowledge and skills necessary to ensure that the installation is performed safely and correctly. Continuous training and education are crucial for electricians working in hazardous locations. They need to stay up to date on the latest codes, standards, and best practices. This ensures that they are equipped to handle the challenges of working in these complex and potentially dangerous environments. In addition to the technical aspects of the installation, it is also important to consider the human factors. Proper communication, coordination, and teamwork are essential for ensuring a safe and successful installation. All personnel involved in the installation should be aware of the potential hazards and the safety procedures that must be followed. A thorough risk assessment should be conducted before any work is started. This assessment should identify potential hazards and develop strategies to mitigate them. The risk assessment should be documented and communicated to all personnel involved in the installation. Regular safety meetings should be held to discuss potential hazards and reinforce safety procedures. These meetings provide an opportunity for personnel to ask questions and share concerns. A comprehensive emergency plan should be in place in case of an accident or other emergency. This plan should include procedures for evacuating the area, contacting emergency services, and providing first aid. The emergency plan should be regularly reviewed and updated. Drills should be conducted to ensure that personnel are familiar with the plan and know what to do in an emergency. The use of personal protective equipment, or PPE, is essential when working at hazardous locations. PPE may include items such as safety glasses, gloves, respirators, and flame-resistant clothing. The specific PPE required will depend on the hazards present in the environment. It is important to select PPE that is appropriate for the task and to ensure that it is properly fitted and maintained. Regular inspections of the work area should be conducted to identify potential hazards and ensure that safety procedures are being followed. Any unsafe conditions or practices should be corrected immediately. A system should be in place for reporting and investigating accidents and near misses. This system should be used to identify the root causes of accidents and to develop strategies to prevent them from happening again. A culture of safety should be fostered throughout the organization. This means that safety is a top priority and that all personnel are committed to working safely. Management should provide the resources and support necessary to ensure that safety is a priority. Employees should be empowered to identify and report hazards and to stop work if they believe that it is unsafe. By following these guidelines, you can help to ensure the safe installation and operation of Class 1 Group D motors and ventilation systems for flammable vapors. Remember that safety is everyone's responsibility and that a proactive approach to safety is essential for preventing accidents and protecting personnel and property. The information provided here is for general guidance only and should not be considered a substitute for professional advice. Always consult with a qualified electrician and other relevant professionals to ensure that your installation complies with all applicable codes and standards. Staying informed about the latest developments in electrical safety is crucial for maintaining a safe working environment. Participate in training programs, attend industry conferences, and read relevant publications to stay up to date on the latest best practices. Share your knowledge and experience with others to help promote a culture of safety throughout the industry. By working together, we can create safer workplaces for everyone. Remember that electrical safety is an ongoing process and that continuous improvement is essential. Regularly review your safety procedures, assess your risks, and implement new strategies to enhance safety performance. The use of technology can also play a significant role in improving electrical safety. Consider using tools such as thermal imaging cameras to detect hotspots in electrical equipment and arc flash detection systems to mitigate the risk of arc flash incidents. Data analytics can also be used to identify trends and patterns that can help to predict and prevent electrical failures. By embracing innovation and leveraging technology, we can make significant strides in improving electrical safety. Ultimately, the goal is to create a work environment where everyone can go home safe and healthy at the end of the day. This requires a commitment from everyone in the organization, from management to employees, to prioritize safety above all else.